See this question. The question says a ball is thrown upward from the roof of a tower 40 meter high with a velocity of 10 meter per second. With a velocity of 10 meter per second, is thrown in upward direction. Find the time when it strikes the ground. Let's draw the figure first. Suppose this is the tower having the height of say 40 meter. This is the ground, and this height is 40 meter. Alright, and from here we are throwing a ball in upward direction. We throw it in upward direction. So as the ball moves in upward direction, since it is experiencing gravitational force in downward direction, it will get deaccelerated. See, the ball will move in upward direction and is thrown with a velocity of 10 meter per second. And since on this ball there is a gravitational force, weight acting in downward direction, so the velocity of this ball will keep on falling, and a time will come when the velocity will become 0, and thereafter ball will come in, start moving in downward direction, and eventually it will strike the ground. Eventually it's going to strike the ground. Alright, so if I draw a coordinate system over here, say this is your x-axis and say this is your y-axis, or y-axis can be like this, it can be anything. Y-axis need not coincide with this ball, right? So suppose the motion is taking place along y-axis. Suppose the motion is taking place along y-axis. I am taking this as y. Alright, so at t equal to 0, and this is origin, at t equal to 0, here y was 0, and finally let your y becomes equal to minus 40. See, this is taken as origin, so any measurement of x right of the origin is taken as positive, any measurement left of the origin is taken as negative, any measurement which is above the origin is taken as positive, and any measurement below the origin is taken as negative. So if you are measuring the y, if the position of particle is above x-axis, then y coordinate of that will be positive, and if the position of the particle is below x-axis, then y coordinate will be negative. So origin is y equal to 0, right? So at t equal to 0, y is 0, and finally particle is here, so y is minus 40, and when the body is in motion, force acting on the body is mg in downward direction. So force acting on the body is mg minus j cap, and this will be equal to mass into acceleration. So your acceleration is gj cap, or the magnitude of acceleration is minus g, right? And this is equal to what? dv by dt, right? Or v will be equal to minus gt plus constant, and at t equal to 0, v is 10 meter per second, v is, that will give you c equals to 10 meter per second. So velocity as a function of time is 10 minus gt, and this is what? This is dy by dt. So you integrate this y, that will be 10 minus gt dt, and that is giving you 10t, right? See, I am doing all these things to make it very clear But we can also use the formula that we have got in the last lecture. The formula was, I told you, when the motion is confined to one dimension, then your formula is ut plus half at square. Here also, see, there I assume that the body is moving along x-axis. Here I am assuming body is moving along y-axis. So the formula will become ut plus half at square. But here a is, since the body is getting retarded, a is minus g. So this will come as ut minus half gt square. You get the same thing from here. So if you remember this formula, you can use it. You can simply use this formula, right? And I'll advise you to remember this formula, right? If velocity is increasing, a will be positive. If velocity is falling, a will be negative, right? So we want to find time t at which your y is minus 40. So put here minus 40. This is 10t, and g is 10. So this will be 5t square. So this will give you what? T square minus 2t minus 8, or t minus 4, or t is 4 seconds. See, t equals to minus 2 seconds is not acceptable. Time will never have a negative value, right? So this is not acceptable. So t is 4 seconds. So body is going to come at the bottom in 4 seconds. Alright. So you can go like this, or you can just remember this formula and put it over here. We'll get this equation directly from here. Getting a point? Okay. Let's move to next question. Our next question is, the question says a ball is thrown upward from the ground with an initial speed of u. The ball is at a height of 80 meter at 2 times. The ball is at a height of 80 meter at 2 times, the time interval being 6 seconds. Okay, find u. What the question means? See, if this is ground, what you have done is you have thrown the ball in upward direction. You throw the ball in upward direction with certain speed u. Suppose the maximum height achieved is more than 80. If it is maximum height achieved, and how do you find maximum height achieved? See, whenever I'll tell you the formula for these kind of questions. Suppose the body is in free fall. We say when, let me give you the equation. When the body is in free fall, then the force acting on the body is mg minus j cap. If I take this coordinate system and the body is having only vertical motion, in that case this force will be equal to ma. So a comes to be minus g, which is equal to, I did it in last question also, but I'll just do it once for all so that you can use it in these kind of question. Body, the motion of body under gravity. The topic would be, I have not discussed it separately, most of the body under gravity. I'll come to this question, right? So v is this, and v is going to be, just integrate it. Let me do it step by step. This is minus g dt plus some constant, right? Plus some constant. So v is, and suppose at t equal to 0, suppose you are throwing the body with certain velocity u. If say v is u, then if you put it over here, you get the value of c from here. C is u. So your equation, velocity as a function of time, is u minus gt, right? U minus gt. Till this vt is positive, that means the body is moving upward direction. If the velocity is in upward direction, you call it positive. If it is in downward direction, you call it negative. So till the time, so what do you find over here? As you throw the body with u, velocity u in upward direction, the velocity keeps on falling. Of course, since the force acting on the body is opposite to velocity, so body will accelerate in downward direction. That means the velocity in upward direction is going to fall. Getting a point? Since the force acting on the body is in downward direction, so velocity in upward direction is going to fall with time, and that's what we are seeing over here. And a time will come when the velocity will keep on falling, and it will become 0. So when this velocity gets 0, let's see that. When your velocity gets 0, that gets 0 after time u by g. So after this time, the velocity will go to 0, and thereafter it will reverse its direction. So that is the time at which the body reaches maximum height. Right? So after this time, the velocity of body in upward direction will be 0, and now it will be starting its downward journey. So at time t equal to u by g, it will reach its maximum height, and we can find that maximum height, but for that we have to do one integration over here. See, Vt is what? Vt is dy by dt. So this dy will be u minus gt dt, and then we can integrate it plus some constant. So integrated, this is y ut plus some constant. So for evaluating this constant, let's call this c dash. So for evaluating this constant, you need to find what is the value of y at t equal to 0. Suppose at t equal to 0, y is y naught. Then you just put this value over here, t equal to 0, and y is y naught. So your c dash will become equal to y naught, and your y will become y naught plus ut minus half gt square. Let this y naught is 0. Suppose if the body is thrown from this level itself, from the ground itself, then your y naught is going to be 0. Moreover, this value of y naught will depend on the coordinate system we are choosing. Like in last question, if I would have taken this as a coordinate system, suppose if I would have taken this as the origin, in that case y naught would have been different from 0. Y naught would have been 40, and the final yt would have been 0. That is also one way you can do the question. In that case, your yt would have been y naught plus ut minus half gt square. So y naught, that will, see, what is the initial value of y? That will depend on the coordinate system. If I take the coordinate system with the origin over here, in this case y naught would have been 0 at t equal to 0, y would have been 0 at t equal to 0. But if I take this as the origin, this as the coordinate system, this is the x axis and this is y axis, in that case y could have been at time t equal to 0, the body would have been here because it is thrown from this position. So y naught could have been, the value of y at t equal to 0 could have been 40 meter. So y naught could have been 40 meter over here, and this could have been 10t, right? 10t, and then half gt square, and you could have found the time at which it will fall on the earth's surface, So finally your yt would have been what? 0. If the body comes at this point finally, so the 0, and you have to solve this equation. So it is same thing. If you make this 40 on this side, it is same as this equation. Get your point? So the initial value of position will also depend on the coordinate system we are choosing. So choosing coordinate system is very important. So your equation could have been this, but if you take the initial position as the origin itself, then y naught will be 0, and y as a function of time would have been ut minus half gt square, right? So just remember this formula, and you can find the maximum height. See, the body reaches maximum height at this time, So you can find the maximum height which the body has. Let me call it y max or say h max. So you just put this value of t over here, you'll get the y max. Y max would be u into u by g, and this would be, so that is what, u square by g. So that is your h max, right? Okay, so just remember this. I forgot to discuss this point in last video. In fact, this was not needed because I discussed motion in one dimension. So in place of x you can write y, and in place of a you can write minus g. You'll get the same equations, right? Okay, let's come to this question. If you find anything which if by mistake I missed something, just let me know. I'll just add those videos also. Okay, see what it's saying. It says a ball is thrown upward from the ground with an initial speed of u. The ball is at a height of 80 meters at 2 times. So what happens if the maximum height reached by the ball is more than 80? In that case, this height of 80 meter will be somewhere, suppose this is maximum height, so 80 will be somewhere below this. So body is going to reach this point 2 times, one in the upward journey, let me use different pen, one while moving upward to this height h. So body reaches, the body passes across this point, body reaches this height of 80 at while on upward journey, and when it returns, of course the velocity will become 0 after some time, and then it returns for h max and then again pass to this point. See, when the body is coming down, again pass to this point and come back. So body reaches this point 2 times, one while it moves upward and the other while it moves downward. Suppose you throw your ball in front of your home, and your house is, suppose it's 4-story building, and you throw your ball such that the ball reaches the height of 4-story building, right, which is the terrace of your building. Then it will cross 2nd floor, 1st floor, 3rd floor 2 times, one while it is moving upward, the other while it is moving downward, right? So if h max is more than 80, of course it will be more than 80, then only it can cross this point 2 times. So it will cross this 80 meter 2 times, and the journey, the motion in upward direction is given by this equation. At t equal to 0, I assume I take this coordinate system origin over here, so y is 0 at t equal to 0. So the equation of y would be given by ut minus half gt square. We don't know u, we have to find u, but we know g is 9.8, but in question people write to take it as 10. If this line is not written, then you have to take 9.8, and if they write it, then you can take 10, but out of yourself you don't take 10, it's 9.8. But if in question they write 10, then we have to take 10. Pay due respect to the people who have given you question. So it is ut minus 5t square, minus 5t square. Okay. Okay. So we want the time at which it reaches 80, plus 80 of course. So you just put 80 over here, and this is 5t square. And see, mathematics is very intelligent. It will give you all the time instant when it reaches 80. It will give you a time instant when it is on upward journey. It will also give you a time instant when it is on downward journey. It will give you both the time. See, it is quadratic equation. It will have 2 roots. So the 2 value of t which you are getting from here, of course quadratic equation has got 2 solution. Then you will get 2 value of t. One will be the value of t while the body reaches height of 80 in upward journey, and the higher value of t which you are getting will be the time instant at which body reaches 80 meter while on downward journey, right? So we can write it like this here, 5t square minus ut plus at equal to 0. Get your point? Okay. So from here it will give you two roots, t1 and t2. It will give you two roots. So one way is to, you can find t1 and t2 and take the difference and equate it to 6. That's one way. The other way, you can use the quadratic equation, the property of quadratic equation. Just do both way. Suppose t is what? U plus minus u square minus, what will be 80 into 5, 400, 1600 upon 2 into 5. So the time when it reaches 80 meter while on upward journey would be u minus u minus u square minus 1600 upon 10, and while on downward journey the time instant when it reaches 80 meter would be this, and this t2 minus t1 would be 6 seconds. That is given in your question. We have to make use of the information which is given in our question. So this is, just take minus, this will cancel out with 2 times six. So this will cancel out. So you just do the manipulation. So it is 1600 and this 30 and 30 square will be 900. Then do it yourself. 2500. So this u is 50 meter per second. Or you can use the property of the roots. You know what is t1 by t1 plus t2. t1 plus t2 would be u by 5, and product of roots is 80 by 5, that is 16. So t1 minus t2 would be what? t1 plus t2 whole square minus under root. So that would give you what? Under root u square by, and 4 into 16 is 64 equals to 6. So you will get from here u square by 25 is, this will be squared, square both sides, so it will be 36 plus 64 is 100. So you will be 50 meter per second. You can do it that way also. So mathematics, it depends on your aptitude, how you do it. Let's look at this question. The question says a particle of mass 1 kg has a velocity of 2 meter per second. Okay. Now a constant force of 2 Newton acts on the particle for 1 second in direction perpendicular to its initial velocity. Find the velocity and displacement of the particle at the end of 1 second. Fine. See, let's draw a coordinate system. Alright. Suppose the body is moving along x-axis. Say it's moving along. Let's use red pen. And let's suppose the body is here when the force starts acting. Suppose the body is lying at x naught distance when a force starts acting on the body in this direction. Body is moving along x-axis. So force will act on the body in y direction. It can be positive y, it can be negative y. Whatever you may take, both are correct. So suppose I take this force to be acting on the body in positive y direction. So this force is acting on the body in positive y direction. You can take it negative y also, no issue. Choosing coordinate system is your right. Somebody can say ki this is my positive y, that is also correct. And see, I told you in the chapter of Newton's laws that Newton's laws can be applied component wise also. This converts to fx equals to mx may fz equal to maz. But since it is two-dimensional problem, so fz is also 0 and az is also 0. This is not useful for you. So what do you find from here? You find from here that if the force is acting in y direction, it will only change the velocity in y direction. It will not affect the motion in x direction. It will not affect the velocity of the body in x direction. See, this is equal to a max I cap a by j cap. So what do you find? Ax is, if you split this equation, sorry, if I split them component wise, what do I get? Max is 0, My is 2. So from here you get what? Ax is 0. And see, when I say acceleration is dv by dt, so if I write this acceleration component wise, A is axy, axj, ayj and azk, and v is vxy, vyj and vzk. So that means your ax is dvx by dt, ay is dvy by dt, and az is dvz by dt. So if ax is 0, that implies dvx by dt is 0, and that implies vx is constant. So whatever was vx, it will remain same. Whatever was vx, it is going to remain same throughout. If applying force in y direction, is not going to affect the motion in x direction. Keep it in your mind. If your force is acting in y direction, it is going to affect motion in y direction only. It's not going to affect motion in x direction. Here the motion will become two-dimensional. This force will create a velocity component in this direction, and you already have velocity component in this direction. You already have, initially you have velocity Vx equals to 2 meter per second, and this force, action of this force will create a new velocity component Vy, and you can get it from here. Mass is 1 kg, so Ay is 2 upon m, and that is 2 by 1, so that will be 2 meter per second square. And this will create a new component in velocity, which is Vy. So from here you get what? 2 dt. Just neglect it. So this will be Vy 2t plus constant, and at t equal to 0, you didn't have Vy component, so Vy is 0. So Vy is 2t. Moreover, you can use this formula also. V equals to u plus at. We apply this for Vy. So initially your Vy is 0. If you apply it to Vy, it becomes Vy naught plus at. Vy naught is 0 at t equal to 0. Body was moving in x direction. Right. So your equation Vy equals to at, that is Vy equals to 2t. A is the acceleration in y direction. Are you getting a point? Or you get this thing from here also. If you remember, I gave you a vector equation. See this equation I gave you. See, this equation will split into, if you put this in this equation, you take this V as Vxi, Vyj and Vzk. Moreover, most of the time you don't have to go for three-dimensional problem, so only taking Vxi plus Vyj would be enough for you. A is suppose, but I am trying to be in general. So A is Axi plus Ayj plus Azk, and suppose V naught is a velocity. Suppose V naught x I cap, or say, let me write it as Vx naught I cap Vy naught j cap and Vj naught k cap, and you put everything over here and just equate ith component the coefficient of I cap, coefficient of j cap, and coefficient of k cap. You put this over here and equate the coefficient of I cap, j cap, k cap. So you'll get what? Vx is Vx naught plus axt, Vy is Vy naught plus ayt, and Vz is Vz naught plus AZT. So acceleration in one direction does not affect acceleration in the velocity in the other. If your acceleration is in x direction, then this ax is not going to affect the velocity in y direction or z direction. Right? Here what do you have? Here in this question, your acceleration is in y direction, since force is acting in y direction. So it's not going to affect the velocity in x direction. So velocity in x direction will remain 2 meters per second. Getting it right? This is very easy, but since you are learning physics, I have to tell you this. Right? Afterwards, when you read 2 or 3 chapters, it will become quite obvious for you. Right? Okay, so Vy is Vy naught plus ayt. Ay here is 2 meter per second square. So you get this relation. Alright. Get your point? And it acts for 1 second. So after 1 second, what do you have? After 1 second, of course your Vx will remain 2 meter per second. Your Vy will be 2t, that is 2 into 1, 2 meter per second, not square, 2 meter per second. So your Vx is 2 meter per second and Vy also 2 meter per second. So your net velocity will be what? Net velocity will be, magnitude of velocity is going to be Vx square, Vy square, you know the vectors. So 2 square is 4, 2 root 2 meter per second. That's the velocity. That's your velocity. Let's talk about displacement. Let's talk about displacement. See, we got Vx and Vy. Vy was 2t. So Vx is what? Dx by dt. This is dy by dt. So if you integrate it, what do you have? X equals to 2 dt integral plus some constant. So it is 2t plus some constant. And suppose the value of x is x naught at t equal to 0. We started from here. So at t equal to 0, x by x naught. So that gives you what? Or you could have taken origin also, but I have been more general, so I have taken this point. So this x is x naught plus what? 2t. X naught plus, okay, 2t, yeah. And from here, what do we have? Y equals to 2t dt plus some constant. So that will give you what? Y equals to t square plus c dash. And at t equal to 0, your y is 0, y coordinate is 0. So that gives you c dash equal to 0. So y is t square. Or if you don't want to do it from the scratch, you can use the formula. What is the formula? Formula is xt is ux naught t plus half xt square, and yt is, but here we have to add x naught also, y naught plus uy naught t. So in x direction there is no acceleration, so this will become x naught plus ux naught is initial velocity and ux naught is 2t. Initially your y naught is 0, uy naught is also 0. So this is half, 2 is the acceleration, it is t square. That's what you have got over here. Get your point? And after 1 second, so you can use the formula also. You can use the formula also, but you must know how you have got this formula. So after 1 second, your x position is x0 plus 2 and y position is 1 and at t equal to 0, your x position was x0 and y position was 0. So what is displacement? Your coordinate over here was x0 0. Body has moved from x0 0 to this. So this distance is going to be, see, when body moves from say x1 y1 to x2 y2, then the straight line distance is going to be displacement. So displacement is given by under root, see, let's call it q, let's call it p. I'm giving a general formula. So dpq, distance between displacement between p and q, or straight line distance between p and q, is given by x2 minus x1 whole square y2 minus y1 whole square. So if I do it over here, this is your x2, so y2, this is x1, so y1. So if I do this, what do I get? x0 plus 2 minus x0, 2 square, 1 minus 0 whole square, 1 square, root 5, right? Root 5 meter. Are you getting a point? Or you can get it from other way also. Suppose the coordinate of the body initially was x1 y1, so you can say the initial position is given by x1 I cap and y1 j cap. The final position is given by x2 I cap and y2 j cap, and then displacement is given by r2 minus r1 vector, which is x2 minus x1 I cap, and the magnitude of displacement would be given by and that is distance formula also. When you read in coordinate geometry, this is the distance formula between two particles, 2 points. So you can use this also. Get your point? So I think I should stop over here. It's already 38 minutes. So I'll stop over here. I'll do the rest of the question.